Proving trigonometric identities, problem type 3. Once again, remember, our goal in proving trigonometric identities is to take an equation and use the properties that we know about the trigonometric functions, the reciprocal identities, the ratio identities, and the Pythagorean identities are going to be the big keys for right now, and try to use that to take the left-hand side of an equation given to us and manipulate it until it looks like the right-hand side. In this particular case, we have cosecant of x minus sine of x over 1 plus cosine of x is equal to the cotangent of x. Now we could, and it's very tempting, to start throwing in properties of equations to play around with the equation. We cannot do that here. That is not part of the process of proving a trigonometric identity. We need to start with the left-hand side You could start with the right-hand side, but the left-hand side is almost always the better way of starting. That's a hint to you that starting on the left-hand side and getting to the right-hand side is easier than starting from the right-hand side and getting to the left-hand side in almost every case. But we're not just blindly working through this. We're looking at what we have. And I see right away that I'm looking to do a lot of condensing. Right? My final result is just cotangent of x. So if I can do something to combine all of this stuff and condense it down, life is going to go well for me. When you don't really see anything else you can do, rewriting everything in terms of sine and cosine is never a bad choice. The reciprocal identity tells us that the cosecant of x is the same thing as 1 over sine of x. So let's just go ahead and do that first. Now I've got a couple of fractions. And since I know that my end result doesn't want to have a couple of things subtracted, my goal is to combine these fractions, which means I need to find a common denominator. There is a brute force choice. Let's just multiply that first fraction top and bottom by 1 plus cosine, and let's multiply that second fraction top and bottom by sine. If you stop and think for a while, there is a more elegant way you could approach this problem, but I'm going to go through and show you the brute force approach because that's probably the one that you will see first. Again, it's not the best way of approaching this problem, but it's probably the one that you will find. It certainly was the one that I would find when I was a student doing this sort of work. So let's make sure that we can handle what happens when we start into that path. All right, I'm just going to multiply the first fraction top and bottom by 1 plus cosine. And then I'm going to multiply the second fraction top and bottom by sine. That's just doing some algebra. Now that I have common denominators, I can subtract across the numerator. Again, just doing a little bit of algebraic manipulation. My denominator is nicely factored. I could multiply that out if I want to, but keeping things factored is probably going to serve me well. So instead of trying to multiply that out, I want to look at the numerator and see if I can factor that somehow. There's no obvious way of doing so, but I do see that I have a sine squared. And whenever I see a trig function squared, in the back of my mind always comes up, is there something I can do with a Pythagorean identity? So let's do one more step of algebra to rearrange things a little bit. And get the 1 minus sine squared x together. Right? That's just the commutative and associative properties of addition, allowing me to shuffle things around a little bit. So a little bit more algebra. But the reason that I did this is that by the Pythagorean identity, 1 minus sine squared is the same thing as cosine. I'm sorry, the same thing as cosine squared. And that's the big thing that we have to notice in this particular expression. We could have also done things a little bit differently. We could have up here on this step immediately gone for the Pythagorean identity and then done some combining like terms, and we'd have had a +1 and a -1 that would have canceled out. There's not really much of a difference there, so either way gives you about the same result and leaves us on this line, which I'm going to copy onto a clean slide so that I can finish this problem off. All right, now that we have cosine plus cosine squared over sine times 1 plus cosine, I notice that there's a common factor of cosine that I can pull out in the numerator. All right, that's again an algebra step, playing around a little bit with factoring. Now there's a 1 plus cosine in numerator and denominator, which will cancel each other out. Which is again algebra. And finally, we have cosine divided by sine. And I remember my ratio identities telling me that this is the cotangent of x, which, if you flip back 3 pages in my notes, is the thing that we said we were coming after. So now we've gotten it, which means that we have concluded our proof.